This comes from the fact that we are in the open source world. We don't try to be everything to everyone. There are things that Asterisk does really well, and there are things that it doesn't do at all, or it does okay, but you wouldn't want to deploy in very large volume scenarios. For example, one of those is being a high volume SIP proxy. So you can imagine if you are a carrier that's providing SIP trunking services to businesses, and you've got 10,000 users, 10,000 companies that are using your service, maybe in aggregate they've got 50,000 trunks between them, the number of calls that in aggregate are being started every second through your network is going to be pretty large. If you've got 50,000 trunks out there, it's probably going to be a couple thousand during a normal business day. Asterisk is not designed in a way that it can handle that. Even though it might be able to handle 2,000 simultaneous calls, it's not going to handle 2,000 simultaneous calls being initiated all at the same time. Now, it's going to slow down, there's going to be problems, it's not going to crash, it's just that you're not going to get the performance you would expect out of that. So what's most commonly done in a community is to use a product called OpenSIR, or its not quite as open source variant, which is called SIR. SIR stands for SIP Express Router, for those of you who don't know that. OpenSIR is a product that literally handles SIP messaging. That's all it does is route SIP messaging around and allow you to modify it and direct it to different places and do all kinds of interesting things with it. So the most common application when you're building an Asterisk cluster is that your clients of that cluster are all SIP. They might be phones, they might be other PBXs or whatever they might be. So people use OpenSIR as a front end sitting in front of their group of Asterisk servers. And it can do things, some things it can do quite easily because people have built these configurations and posted them on the internet for you to learn how to do it yourself, to do things like load balancing. So maybe you have 6 Asterisk servers, and in front of that you've got 1 or 2 OpenSIR machines. And every time an invite message comes in from one of your SIP clients, the OpenSIR box looks at the Asterisk servers to figure out how busy they are and decides which ones to send the call to. That sort of thing can be set up with OpenSIR in about 15 minutes. It's just trivial to do. What that means is we aren't going to make any attempt to try to do that inside Asterisk. There's no need to reinvent a wheel that's already out there and works really well. Same thing is true for some of these other products that are up there. Asterisk has an interface called the Asterisk Manager interface, which allows you to monitor what's happening inside an Asterisk server, see what's happening to all the calls and all the channels, and actually originate them and do lots of other things. However, again, since it was originally designed to be a PBX, that interface is very server-centric. It doesn't have any ability to cross multiple servers. There is a project out in the open source community by one of our community developers called AskMan Proxy that takes care of that. You put that on a machine in front of a cluster of Asterisk servers. Now you can watch all the activity that's happening on all those servers through one aggregated interface. And you can do monitoring of all of them through one connection. And then finally, for people who are doing clusters for doing things like redundancy and failover, there's a project out there called Linux HA, which is a framework. It's not really a product on its own. It's just a framework and a bunch of tools to allow you to say, all right, I have this server and I have this server. This server is going to provide my services normally, and this one's going to be ready to take over for that one if anything should happen to this one, and there's lots of different ways to define what that means. So again, there's no reason for us to build in Asterisk the ability to take over for another server because it can already be done. What that means is if you're looking at building a large cluster of Asterisk servers, or even a medium-sized cluster, you're not just going to be using Asterisk and Linux to do that. You have to learn that there are other pieces to this puzzle, and these are the most commonly deployed pieces that people use to do these things. There's lots more, but these are really the 3 important ones that you have to know about. All right, so now we'll look at some of the ways that Asterisk clusters are used to provide services, and we'll start with some of the simpler things. Not that voicemail is just actually all that simple an application, but in terms of the way you deploy Asterisk to do it, it is one of the easiest things you can deploy Asterisk to do. And this is actually a very common way that Asterisk gets into networks, whether those are enterprise networks or carrier networks or whatever, is the voicemail service, the voicemail system that's available with whatever telephony platform they already have may be outdated and needs to be replaced because their vendor's not supporting it anymore or whatever it might be, or it doesn't support the functionality that they want. So they choose to use Asterisk to do that. Prime example of that is University of Pennsylvania in Philadelphia. that is just about ready to start deploying Asterisk as a voicemail platform for their initial population of 7,000 people, headed towards about 80,000 people. They use Centrex from, I guess it's Verizon is the ILEC here now. So you can imagine that they pay a large amount of money for that. It's 25,000 lines on Centrex. I'm sure the bill's quite large. And for the longest time, they've provided their own voicemail service. They haven't paid Verizon for a voicemail. But that voicemail server is a very old Octel voicemail system. They're not interested in upgrading anymore. And it doesn't have any connectivity to do things like unified communications. Can't connect it to do faxes. Can't hook it up to an email inbox or any of that kind of stuff. All those things can be done with Asterisk, so that's the direction they're going. So this is the way that people do these sorts of things. And we have a lot of functionality in Asterisk today that makes that pretty easy. Second point there is really for connectivity. Obviously, doing voicemail for a voice over IP network is fairly simple because you're just forwarding the calls over SIP or whatever protocol you choose to the voicemail server. But we can even do this off of traditional PBXs, and that's what the people that are doing it off of Centrex are using. And we have a large number of ways, well, 3 at the moment, more in the works, to cluster those servers together so that the voicemail is all stored in a central location. As an example, it can be done, well, it can be done with databases. The most interesting one that's being developed now, though, and the one the University of Pennsylvania is using, is to actually store the voicemail in your mail server. Because where do your users want it anyway? They want it in their inbox, right? So instead of sending a copy of their voicemail to their email address and having a copy in their inbox and a copy on the phone system, we can now natively store the voicemail in your mail server. Well, your IT guys are already building a clustered infrastructure for your mail system, right? They already have multiple mail servers and a big back-end storage mechanism and backup processes in place and all that kind of stuff, which means that you can leverage that and say, well, we're just going to put some more stuff in there. So this becomes if you're using mail storage for your voicemail, it probably would take less than a day to set up a cluster of 2 Asterisk servers, redundant so that the calls can go to either one and all the voicemail stored in either one and can be checked from either one because all the tools are there to do this already. The one thing we do not have today is if you are actually doing this for SIP phones, not PBXs or off of Centrex or anything else. We have some problems at the moment with making sure that the message waiting lights on all the phones work correctly depending on which server the voicemail gets left on. That's a really technical detail you don't have to worry about unless you're really deeply into all of this stuff, except that we have it fixed and it will be fixed in the next release. So the next major release of Asterisk that comes out supports this already. And the reason that's relevant here is the method that was used to build that is a way, let's see what's the best way to describe this. It's basically a way to federate a bunch of Asterisk servers together so that state changes that happen on any server are immediately broadcast to all the other servers. So all the servers are aware of what's going on in the network. Today we're only using that for message waiting notification for voicemail and a couple other things, but it will start to get used for a more powerful functionality too once it's out there and users can actually use it. Today it's in a development release, so nobody can use it really. The next way that Asterisk gets used, again as an adjunct for existing systems, is to provide conferencing services. We see this actually quite a lot, especially in the medium-sized business market where they've bought a phone system that might have 200 stations on it, but they don't have any conferencing. Other than maybe a local conference of 2 users or 3 users in a phone, they don't have a way to set up a conference room and manage it via any sort of system. Asterisk has the ability to do all of the things that we've got listed up here already, and probably a lot more than that. And even because of the management interface, Asterisk audio conferences can be managed via web interfaces. So there are, I think, 3 or 4 open source, well, one's not open source, one's commercial, and 2 or 3 open source systems out there on the internet for managing conferences via web interface. If you imagine, I don't know how many of you, I don't know what the general population of enterprise versus carrier people here are, so if I offend any of you by mentioning company names, that's sorry. But if you imagine, there's the carriers make a ton of money selling conferencing services, whether that's AT&T or whoever it is. You go to their website, you have an account, you schedule a conference to happen at a particular time, and you might list all the participants, and some of them even allow you to place calls out to the participants now as opposed to making the participants call in and put in PIN codes and all this other kind of stuff. The actual infrastructure that's required to build all of that is pretty much dirt cheap nowadays. It's PC-type servers and some software running on them, and in some cases is Asterisk doing that. What we've also demonstrated a couple of times, although I can't say that I know of anybody who's deployed it this way, but I'm sure it's out there, is the ability to actually have distributed conferences across multiple servers. So if you can, as an example, you might have a company that's got offices in, Los Angeles and Denver and Chicago and New York and Dallas and things like that, and they might have people in all of those locations that want to join the same conference. You don't want them all going to a single server at a single location and all being conferenced there. You have local conferences on all of them that then are mixed together. And actually, I see some people raising their hands because they've probably done this. So